Okay, we have something really different here today. We have something I just came across at random on the internet. This idea that this thing we have here, the square root of n times 1,000, is never an integer. Now, I don't know if maybe I misheard this or if maybe there's some conditions on n that can make this possible. I mean, of course, if like n's not an integer, that would do it. There could be something I missed. They might have made a mistake. Who knows? Now, clearly, one thing that is true here is that the square root of just 1,000, that's not an integer. That's going to be something, that's going to be a number between 31 and 32. But this general statement that this thing is never an integer, this is easy to disprove because all we need to do for n is if we make n 1,000, then we have the square root of 1,000 squared. That's just 1,000, which is an integer. So it was real easy to show that this was wrong, but in my mind I had some other questions like, when is this going to be an integer? What does n need to be? How many integers can we get out of this? And then also, what is the smallest n that we could choose so that this is going to be an integer? So for the question of the smallest n, I think we have a way to do this. So to find the smallest n, I think what we want to do is start by getting the prime factorization of 1,000. Now you can look at 1,000 as 10 cubed. I like to look at it also as 8 times 125 is equal to 1,000. But if we just rewrite this 8 times 125, and we could use either one, it doesn't matter, but 8 is going to be 2 cubed, and 125 is going to be 5 cubed. And the thing to know here is the only thing we need in order to have a perfect square is we need, in the prime factorization, every term needs to have an even exponent. So what we need this to be is we just need this to be 2 to the 4 times 5 to the 4. If you write that out, that's going to be 16 times 625. And if you multiply this out, this number is just going to be 10,000. Or you can think of it like 100 squared. And so in order to make this a perfect square, all we need to do is kind of go from here to here. If we multiply it by 1 copy of 2, 1 copy of 5, this is going to be our n value. 2 times 5, this is just 10. This is going to be the smallest value of n that makes this a perfect square. And then that way this is going to return an integer. So that's good that we found this value, the smallest value of n that's going to make this a perfect square. We had that other value that we found, n being 1,000, that works. Then the only question I have left is what other values of n can we use in order to have this be a perfect square? Well, I think I want to write this out a little differently because we're going to use this n value that's going to make it a perfect square. So we know that this thing is going to be a perfect square. But then if we multiply in some other value, we'll call this k squared. Now let's say k is a positive integer. This also is going to always be a perfect square just because we can split this up. I can write this as k squared times this thing, n times 1,000, which we already determined is a perfect square. If we just multiply it out, we determine that this is actually going to be 100 and this is just going to be k. And so it turns out we can get an infinite number of perfect squares out of this when k is any positive integer. You can include 1. I mean, 1's just going to give you the same thing we found earlier. But going through any integer, you can plug in 3 or 5 or a billion, and no matter what you put in for k, it's going to return this perfect square. Okay, there you have it. Random, weird problem I found on the internet. Thanks everyone for watching. Have a good day.